It's September 22nd, 2023. We're in Active Inference Institute. We'll see how we can extract information from a video in the Institute's YouTube site in several different formats: video, audio, and text. We'll go to the Institute site here, and we'll select playlists, and then select the particular playlist that we want to work with, constructing cultural landscapes. Now we'll halt this first video that comes up because that's not the one we want to work with. We want to work with number 8, which was just published in the last couple of days. We'll start that up. I'll halt that, and we'll just look at a couple of things here to make sure that the video is finished with its processing in YouTube. We can turn on the closed captioning, and that's fine. We'll start it rolling, and we should hear and see. There we go. Not only do we see the closed captioning, we see it in Chinese, because YouTube has had enough time to set up their auto translation. Right now it's set in Chinese, and we can also get it in Dutch. Okay, so now what we have to do, you'll see if you look at the address bar, you'll see that there's a playlist listed here. We don't really care about the playlist for our present purposes, so we'll just capture the basic URL, including the 11-character YouTube video ID, just to make sure we've picked that up. Yes, we have. It reloaded properly. Now we're going to take just that 11-character ID, and we're going to move it into a form that we use to track our work with these videos. Anyone who works with this facility, you'll have access to a spreadsheet like this in GitHub that you can use on your own. Now, here we'll put the ID that we just copied. We'll also capture the, now we're ready to go ahead and capture the audio. So we take that URL, you don't need to keep playing this, and we'll go to a piece of freeware. You can give them money and they'll reward you, but you don't have to give them money. The 4K video downloader. We click the paste link. We've already loaded that link into our buffer. So we take that, we paste that in there, and now we get some defaults. There's a couple of options about what you can download. You can, at each time you use this tool, you can either download audio or video. We'll go with audio. There are several formats that 4K downloader will use. We'll use M4A, which is the highest quality that we can use with our other software packages. We always use the highest quality in there, and we now need to say where we want that video file to go. I've already set up a directory structure for our use. We mentioned that the playlist is Active Inference for the Social Sciences. This is session 8, and I've created a YouTube folder to hold the information that I download from YouTube. Here we have the name of the file name, and there's a little problem the way this has been set up in YouTube. If you put parentheses in, that creates some extra work. So we'll get rid of the parentheses, and we'll copy this file name. This will be the local file name on my local operating system. We'll start up the download, which takes a little while. And we'll now go over and make sure that in the slot 8, for video 8, that we have the right name in here. Oops, and we don't. What I need to do is to pick up the file name that's being constructed. There we go. And you see we've gotten rid of the parentheses. We go back to our spreadsheet and we insert that video ID name. It's really a local file name, not really an online name. So that's there and that's good. We need to fill out a few other things. I've pre-filled a few of these things. This is hours, minutes, and seconds. We'll need that later on. We'll check, did I get that correctly? Well, we can go out to the file system. We can say properties, details. It says 1 hour, 20 minutes, and 20 seconds. Well, I put in 27 seconds. Let's just put that, let's correct that. And it actually gets the total number of seconds duration. Now we also need the file location just so we keep track of where we are. That's up here. We copy that, we put it into our spreadsheet in the file location. Okay, that's good. I'm going to save this work. Now there's an online folder where, unfortunately, the way I've been able to use Assembly AI, I have to use a kind of intermediate location. I should be able to upload directly from my local directory. I haven't been able to do that. You'll see that this 4K video downloader has finished. We get a set of selections that include show in folder and open link in browser and copy link address. That's a way of going back to the place that you found the video in YouTube. So now what we'll do, we're going to start up. I need to move this off. I need to copy the video file, the audio file, onto a web location. Well, I have a website that I use for that purpose. We'll see how to do this. Okay, you notice we've already got that same location, except that the YouTube folder. So now we have exactly that same location we looked at before, where the local file is. And the directory on my website is already set to active inference for the social sciences. So I can take this and upload that audio file. Upload in background, make sure it's binary, and this particular tool also has a way to say new and updated files only, so that if I want to be careful not to overwrite an existing file, I don't have to worry about that. So that's going to take quite a while. I think we'll pause the video for a moment. Okay, the file upload is finished. We need to make sure that we have the correct location on the website. I will copy just the parts that can change. htdocs is where essentially all user files are. We need to go back to the spreadsheet and make sure that that online folder location is properly populated. Okay, and we'll just compare that with the previous location. That's the correct, that's the same, that is what we'd expect. Now we are using functions that compose the proper invocation of our Python script, and we'll just copy that from the last time I ran this for this same series of lectures. Okay, so there we have that. It says submit to Cloud Whisper online. Now we do have to do one more thing. We said that we were going to work in this file location, so we now need to copy that and open a Linux window. So we'll start up Ubuntu. We'll move to the proper location first, the local name, mount point D, which is the way Windows files are addressed in this Ubuntu. And now we will drop in that Windows folder path and fix it up to work in Linux. Someone was saying that Bill Gates' decision to use the backslash instead of the forward slash was the one decision he made that has cost the largest amount of wasted time over the decades. Okay, so now we're in that same file location, and where we happen to have put our audio file, and now we'll run our assembly AI. Oops, made a mistake, sorry. We are not going to use that location. We're going to use the assembly AI folder, and same thing, we have to move up and to, that's file path completion. We're now in assembly AI. You see the local location of the audio file doesn't constrain assembly AI. We're just doing this in a way that will avoid confusion. Maybe not minimize, but reduce confusion. Okay, so we want to use this script that's been constructed. I'll show you what that actually looks like when all of the calculations are resolved. We'll drop this in. You notice at the very end there's an at sign, or an and sign rather. That causes the script to be run in background on my local Linux instance. So we're going to fire that up and see what happens. If we go back here, we'll see that remember the assembly AI folder was empty, but now there is a trace file. That's what's generated as the output, the actual net output in standard out. So this process in assembly AI might run for 20 minutes, so I'll stop the recording for a while and we'll be back with you in moments. Okay, you see that a lot of files have been returned locally to the assembly AI folder that we're building into. We can take a look back in the Ubuntu window and see if it's finished processing. You'll see it puts this wisecrack, thanks for the call. Or if things break down, it'll say something like, call if you get work. But this is completed. We might as well hit return, and that closes that output file. If you come back up here to the directory, you should see the text file that we were teeing into. T is a basic Unix facility that copies its input into both standard out and also into a file. So the next item has to be a file name. So what do we have up here? We'll refresh again. We have a bunch of CSVs and one SRT. Let's take a look at a couple of these. The SRT is actually well formed. We can use it. It's not the ideal container for the information we would like to have displayed as closed captioning with our video. Essentially, it doesn't have the speakers' names. Let's also look in the sentences CSV and see how that lines up with this SRT. Now in the spreadsheet tool that I'm using, LibreOffice, you have to tell the spreadsheet program the format of CSVs. It doesn't go in and look at them like some more expensive programs do. So we'll open that, and they both the SRT and the CSV start out with the word you, hello, and welcome. Now, it might seem a little odd because Daniel doesn't usually say you at the beginning of his talks. Let's go into the actual source video. We'll listen to that and see what actually is the first word that's spoken. Okay, it doesn't seem like he says you, it seems like he says hello. Let's go make sure. We'll look at our auto-generated English, run it all the way back to the beginning. I've turned on closed captioning in English, and we'll just watch. Okay, so this is something that very often happens. I think most of the time you get this spurious word you at the very beginning. So you know what we can do? Let's make a copy of the CSV file, the sentences.csv. Okay, we can't do that because the path name is too long. So we'll just delete this. U doesn't do anything. And dropping words from this CSV doesn't actually destroy anything. It doesn't ruin the alignment between the text and audio on the one hand and the tape on the other, the video. So we'll just, because the start and end is the time points in milliseconds, so we'll just save this and close it. And we might as well just do the same thing. We know that that first word you doesn't correspond to anything real, so we'll just delete the word you and save it. Okay. Now we're going to have to do a little bit of manual adjustment in order to identify the speakers in a good way. We'll go back and reopen the CSV. Open that back up. Now we want to do a couple of things. Let's put indexes on. They're called filters here, auto filter. This allows us to look at the entire file all at once. We have only two speakers, or I should say Assembly AI has identified only two speakers, A and B. And we see that after we dropped that first item, speaker B is the correct speaker. We need to record that. As we remarked, Assembly AI has identified only two speakers, and the first of those it labels as speaker B. Now we need to do a couple of things with that information. We need to go back to the original video and make sure who speaks first and make sure who speaks after that, and we also need to record that same information in a reference file that's used to assign those speaker names in the next stage of the transcription activity. So I've just pulled up the video in YouTube. We're going to turn on the subtitles and we're going to listen to this, make sure who the first speaker is, the one who's labeled B. And is, as usually the case, Daniel is the first speaker, so that we know that B is the label for Daniel. We have a central location where we record all of this material. It's allspeakers.csv. There's a copy of that in GitHub, but that will need to be updated and moved in a location that's convenient for the scripts to find when the transcription process has been productionized. So, as I mentioned, we need to explicitly say which separators are being used, and of course CSVs don't know much about formatting. They contain only raw data, so we'll make this a little easier to look at. And we have to find the prefix that's already CCL2023. So we can just do a search within the current selection, that is column 1. Okay, that's actually a prefix. And where did we get that CCL? CCL2023-8. That's what we see in the file name, and that's also what we saw in that collection of invocations, CCL2023. So we'll look for that here. Find next, CCL2023. And we have 8, and we have only 1 slot. This is the all speakers. For every line in all speakers, within each session, we have to have one row. We actually have 2 here. Now the first speaker is B, and that is in that first column, column 3, we have the name that's by which the speakers typically address one another. Perhaps at some time in the future we'll tie that into voice recognition, but for now this is just labeling that will be generated in the various text files. The second speaker is labeled A, and we see over here that seems to be Mao, and that's right, and just checking the correct spelling of her name. Here we go, Mao Albarracin. So we'll make sure that that goes in here. We want to make it nice and clean, no trailing garbage. Mao in the first column for speaker and her full name in the second. Okay, and we save that. Okay, so we can just take another glance at how this is set up. Does it seem to make sense? We said that speaker A would be Mao, and sure enough, the first occurrence of A, Daniel had just spoken to her, says, Mo, we're going to pass this over to you, and she says, awesome. So this is actually very simple and straightforward. We make sure that that's saved, and now we can generate the next stage in the processing of texts. So we will go back to our Unix window. We're still in the assembly AI, and that's fine. We're going to now locate a call to Python that's appropriate for using the information that we've already gotten from assembly AI. In fact, that's a file called sentences.csv and a file called paragraphs.csv. Each of those supplies specific information to the next Python script to be invoked. And we also will use the allspeakers.csv. So I'm going to take the same outline, the same functional, perhaps, that I used for the immediately previous tape in this, video in this session. We're going to use a thing called sentences to transcripts, a Python script, sentences to transcripts. I'll show you what that looks like, what that call will look like when we pass it to Linux. And sure enough, there it is. There's the invocation of the Python script as the first argument passed to Python 3, actually what Python considers argument 0. The second one is that CCL 2023 session 8, and then a dot, which stands for the location of the incoming files, and then the name of the sentences file. That has by far the most information that will be used by this Python script to generate files that are easier to work with. And then the output of that simply goes into a trace file, transcript.trace. Okay, so we'll take this entire command as it's created in that spreadsheet. We'll drop it in here into Linux. Sometimes it doesn't work very well. Right click. Okay. And there it is. That should be, just eyeball this. It does call Python 3. It calls sentences to transcripts. The label for this activity. Where is it? Where are the data? What's the name of the sentences file? And then a way to capture the output. Okay. We'll submit that. And we get a bunch of scrolling information, which we don't have to look at. That's for debugging. Now let's go back and take a look at the output. Okay, we'll refresh that, Control R on my operating system. Very long file names, very long directory. That's not very good. That might be fine on Unix, but on Windows, certain activities break down. Okay. Let's look at the timestamps. You see, 9:45. These are the 4 files that we just created. All the rest of these were created. We updated the sentences. Remember, we deleted the first word. It's a spurious word, you, and the rest were generated prior to 8 o'clock, prior to 9 o'clock my time. Okay, So now we'll look at these. What's in the text file? That looks like that should be nice to work with. That is simply printable text. We don't recommend that people edit this, but it's a very nice format to print out. Here's the other one, the output that we want to work with for editing. There's going to be, of course, a lot of misrecognition of words by Assembly AI. The punctuation is often rather poor, but see, this is pretty legible. This is reasonably close to what's being said. The only time that it gets really bad is when the voice quality is very bad or the speaker has a heavy accent other than English. So this looks okay. So this is our most important single output. So what we're going to do now is just go ahead and move that into GitHub. So we will now open up the part of GitHub where we store these. I use a tab called ActInfJournal, and that opens at the top level of the journal information. This is going to be the source when we move files. Oh, by the way, we should check for anything with a zero length. That typically tells us that something's gone wrong. Okay. So out in the Active Inference Journal, this is a CCL, which is considered a course. And that is Active Inference for the Social Sciences. So we know we're in the right playlist, or the right volume of the Active Inference Journal. And this is the lecture for norms, scripts, narratives. Okay. We should look carefully at this. These are not numbered. They don't form any particular numbering order, but that's the correct one for this. This is Mao's lecture under that topic. So now we go into transcripts, and the transcripts, these are the captions, HTML, and prose should contain essentially the same information, but in different formats. So let's go into prose. We said the form of prose that we want people to work with is the markdown, the .md. So we're going to move that down here, and that's uploaded to GitHub. And I've in order to avoid figuring out what we have to call these, how we need to describe each commit, I've made a little cheat sheet that I call GitHub comments. So what did we just do? We just created a transcript. It's the prose transcript. The commit name or activity description that I'm using for that, these can't be very long. Add files via upload. What is it? It's a transcript. So we just put that one word transcript in here, and then we look for a description of what happened. We have a fairly large amount of text that we can put in to describe what we were doing. Well, how did we get that transcript? We got it through 3 pieces of software. We got it through a thing called Submit to Cloud Whisper. We got, actually, Submit to Cloud Whisper.textbook, just an arbitrary, just happens to be what we call that version, the current version. We used Assembly AI, and we used sentences to transcripts. I made a small adjustment to that Python script today, so in my timestamp for the software, that's in this cheat sheet. So we put that in there. We say, okay, what have I done? I've got the markdown. It's the transcript. It's for active inference for the social sciences. It's the norms and scripts. It's the prose format. So we'll go ahead and commit that markdown. Okay, unfortunately it throws us all the way up to the top. We have to go back up to courses, active inference for the social sciences, norms and scripts lecture. Transcripts, we have another form of transcript. We have the SRT. Now this is a mistake. I apologize for putting nonsense in here, but that was just from working in what for anybody else is bright daylight, but I was working at night, so that's how that happened. What do we have now? This is now a captions file. So first we'll move the file. We'll copy two things. There are two things that we need to move. Now you may have noticed, if you've looked at the CC options for translations for multiple languages in the Active Inference YouTube site, there's two different places. There's two different English versions of the English. One is more sophisticated, and that's this one, M4 ASRT. Let's look at that. What are the characteristics? There's no speaker labels, and the formatting is all correct. So this is the one that we're going to use. How can you tell which is which? Because there's another SRT here. This one that was created recently. There's a bug in the code, so we should not use that. This is good enough, though. Here's the odd thing that we have to do, because we want to give people the most literally accurate, the most accurate word-for-word transcription of exactly what each speaker said. We're going to label this EN to show that it's a transcription of the original wording. It's not a translation. And we label it, this is an arbitrary label, Irish. It's as though the Irish were to speak word for word absolutely perfectly, but they don't bother with punctuation or capitalization. It's not true, but that's what we pretend is true. Okay, this is what I said about these being too long. I'm going to have, in order to relabel this, I have to make a copy of it. I'll just put it in somewhere arbitrary. I'll just create an arbitrary file. New folder, just call it new folder, why not? We put that in there. We change this SRT name to EN. IE. Again, just to see what we're doing, this is the correct word for word directly out of I'm sorry, this is the version that was generated by Assembly AI. We go out here, we make sure we're looking at the right things. This is the renamed version, and we just drop it into the captions, transcripts captions, that is English language captions. Okay, and there is another version. The one that's more word for word accurate is the one that comes out of YouTube, but we haven't done that. So let's go do this. This will show you the other activity. Remember we said that we can pull two different kinds of information, two different groups of information out of YouTube using the 4K video downloader, 4K video downloader. We take that URL for Mao's lecture. We drop that in here, and this time, instead of generating audio, we're going to generate video. And the containers, once again, there's more than one container available. We use MKV as much as possible. That's called Matryoshka. And it's if we possibly can, anywhere in active inference, we work with videos in Matryoshka format, MKV. We're going to select a high quality video. We're going to go in here for subtitles. And you'll see there's a number available. Well, I always select all of them. Most of these languages we have some people on the project that speak them. Some of those are highly utilized. Russian, Portuguese, Spanish. We have some French speakers. So just select everything, including English transcription. That's what I was describing as word for word, highly accurate. We can check again, make sure that it's going into the right folder. Okay, yes it is, that's the right one. And we'll see what happens when we press download. File path too long. Well, you know what we're going to have to do? We're going to have to move it into that dummy folder that I just created someplace else. Okay. So take the name of that folder, just drop it in here. Let's see, we have to do this whole thing all over again. That's fine. Pick this up, put it in the system buffer. Paste the link, it goes out, it does the work that it can. It's still going to extract video, MKV, all the available translations, high fidelity, and this time we're going to select a different location. We have to take this folder path, we drop it in here, okay, enter, so it uses that. We will go ahead and leave this the same, but remember when we're downloading things, we want to get rid of the parentheses and we want to keep the file labels consistent. So this should be, if we were to take everything except the extension, this should be exactly what we've been using for the audio and the generated data files and so on. So get ready to go, see what happens. Now this is an option. Do you want to download everything in Active Inference Institute? No, I don't. I just want that one, and I hope it lets me do it. Yes, it does, sure enough. It's already started to bring these down. 4K video downloader is a little delicate. It's easily confused. So if you do something like sort the output, that will often make it reset and reload everything a second time. So to keep things simple, we're just going to allow it to keep working, keep downloading. It seems to think it's finished, but I don't think. Yes, indeed. Let's see what's happened. Has it completely finished? It looks confused. It looks confused. It looks like it's not actually downloading the MKV. I think that's okay, because for what we're doing right now, we only want to get these SRTs. So, you know, to keep things simple, I said 4K video downloader could get confused. I'm going to simply shut it so it doesn't stomp on me. Let's sort by SRTs. Okay. We got one SRT. Remember where we got that? That is the output from Assembly AI. We have a whole bunch of other SRTs, but only one in English. And we're going to change this. I made a mistake. This This labeled one, this should be called CA. Totally arbitrary, we use IE for highly accurate word for word, but with little punctuation, and we use IE to label the English transcript that is highly accurate word for word with little or no punctuation. Okay, that's going to be described in the textual write-up also. Okay, so what were we trying to upload into GitHub? We were uploading the English SRTs into captions. I'm going to delete that because there was an error in the file name. We'll go back here. This is, and we'll just verify what we're calling Irish English, the word for word accurate. Yep, sure enough, very little punctuation. But if you go through this word for word, if the speaker repeats the same word, if the speaker says those will be represented. So word for word accurate transcription. And that's labeled IE. The CA should have punctuation. It should have capitalization. So good for us. What we're going to do now is take just those two English, consider them transcript captions. We'll take these two English transcripts, just the two, copy them in here, and now we need to describe what this commit is about. They are captions, and they have two different sources. The IE, you kind of scan through here, you should see a couple of places where we talked about IE. Here we go. The software for IE is only auto-transcribe from Google Yoo-Hoo, and the CA went through Submit to Cloud Whisper and Assembly AI and Sentences to Python. So we'll copy that, type captions, and put that detailed description. How was this particular caption generated? If we go back and audit our work and discover that certain work was done incorrectly, having these stamps, these kind of provenances, might be useful in future. We say, oh look, everything between June and August 2023 is wrong, but the stuff before that is good. Look at those timestamps. We'll see where the software was changed. That might make it easier to catch up with past mistakes. Okay. We're going to go back into the courses, put some more files into GitHub. We're working with the lecture for norms and scripts. We're now going to capture the translations, move the translations into a public space. Well, we've already got all our SRTs together, but we're not going to move the English this time. I don't want to move any file to more than one location. That just kind of defeats the purpose of organizing them. So we'll take German, Spanish, French, Italian, Japanese, Korean, Dutch, Portuguese, Russian, simplified Chinese transcription, and traditional or Taiwanese Chinese script. Move them up there. Find the translation, the description for translations. Translations now, we are not using any homegrown or any expensive translation software at this stage. So we will describe what we've done is simply using the Google and YouTube automatic translation engine. Okay, and there's a bunch of these, and we'll save that. Okay, and we've got just one final group of files to move up. The last group that we want to capture to GitHub is the metadata. So we'll go back into GitHub, Norms and Scripts Lecture, Metadata. Now we don't have this subdivided at the moment, so we just identify the metadata in the assembly AI directory. So essentially all of the CSVs, well, we'll just pick up everything and then drop the things we don't want. Look for anything that is currently open, these sort of stubs that are created for a sentence, for a CSV that's open, ignore that. Any SRT we ignore. We ignore the type down, the text that is that contain transcripts. So what do we see? Here's a bunch of CSVs. None of those is a backup of anything. Transcript trace we do not need. There is a group of files that are created at the end. 3 JSONs, which are the full raw data that comes directly out of Assembly AI. And there's a small file, normally it's 1K, created at the same time as these, just transcript.trace. So we will take all of these things, CSVs, most CSVs, all the JSONs, and one of the text files, and we'll copy all of those up to GitHub. And we'll go look for the descriptor of the commit. It's called metadata. This doesn't look good. What just happened? I tried to copy all of these items over here, and it doesn't seem to like it. It looks like it may have copied only the sentences.json. Well, let's see what happens. Well, that's not good. What's happened? Is the repository full? I do not know. But I have to give up for now, and we'll talk to the administrators and see if we can straighten that out. So I think we got a little bit done. You see a little bit about what the process is. We pretty much covered the normal cases and a few of the things that can go wrong. So see you later.